Here we go again. So just chronoed it with a 0.45 and it's between 2.7 and 2.75 joules. I fitted the mag pull grip just because I prefer that one. I think I will be replacing it with the Reptilia grips that I actually prefer on basically anything. Also tried to mount the front guard extension just for you guys to show. As mentioned, this will be a short rifle, so I won't use it, but just thought I'd share the looks of it. It clamps onto the vertical rails and it have M-lock rails for you to mount bipods. This is the cheap plastic version. There's also like an aluminum extension that's meant to go on the front rail to have a further away point for the bipod to rest on. It's actually surprisingly easy to load and the trigger pull feels decent. Let's take it apart and see what's inside. So hope I'll keep it in frame. I haven't done any of these sort of unboxing tutorial thingies, take apart videos before, and it's just filmed on my iPhone, so let's try that. Here we go. 3 screws. Oh, nice. There's actually a small place to keep the mag catch in place when you take it apart, which is really nice. Not too much to say about that. So it looks to be the cheaper version of their 90-degree series. There's, from what I understand, there's a black and a red version. The red being the more premium one and this one being the cheaper one. From what I read online, both should work fine. I think the red one is a 2-stage trigger where this is a 1-stage. There's also this sort of safety that you can pull the trigger if the handle isn't down. I'll be removing that safety thing anyway. I never used it in my bolt actions. Yeah, let's take it apart. What's that gonna be? A 3. Let's take off the barrel first. Oops. And this one. Let's get a box for the screws. There we go. So on my other builds, I don't ever keep that one and that one in place because I think it just makes it take further a longer time to take apart. There we go. So everything is extremely dry and not lubricated on the outside. Also not the, does it use the POM rings or what does it do? Let's check for seal. Okay, not too impressed about that initially. Let's try again. Nope. Definitely needs some work there. Let's pull off the triggers here. They have these. Yeah, that actually worked. They have like a quick release for the shear. I wonder if it's a 7 or a 9mm spring. I think it's a 7. I actually really like the maple leaf. They have the thick part of the nozzle out here, so I think they create a stronger air seal. And if you look in here, they does still use the sort of what's called POM or nylon rings to maintain the position of the cylinder. There's a lot of guides online on how to create sleeves that you put into the outer barrel to make the cylinder more centered. And I think that's really worth looking into. If you have a 3D printer, it's extremely easy to print for the different variants of the cylinder. Yeah, look into that. So let's take the cylinder apart and see what we have inside. Where's my cylinder tool? There we go. This is a Trido cylinder tool. 7 or so yeah, 7mm spring guide. I always used 9mm spring guides in mother builds, and all my springs and spare springs are that, so I'll change this one to that one in the future. Let's see, there's a thread for an air brake. It's actually pretty well lubricated. Why isn't it holding up more tight? Let's try to give it a little bit of grease. Let's see if it fixes anything. The cylinder does feel relatively dry. A little bit of groove as well. There's something that looks like a 2 to 3mm padding on this one. It's really tough. Let's see. So let's see if that helped anything. Why isn't that one? Oh, let's put that one down. Again, push this one down before you can put that. Oh, this one catches like that. Put in the spring guide here. Is that all the way? No, it's not. Why is it all going all the way in? Let's look down into it. Oh, like that. That's not too impressive. I think we might try with O-rings and stuff like that in the future. Anyway, let's continue. I think I'll remove the safety thingy. Let's take it apart before we remove the safety thingy. There we go. And let's push this one again. So this is the 90° shear. I haven't tried the Maple Leaf version before. I've mainly used PDIs as I think they're the most what's called durable. I had the PSS 10 from Leylax before, and they blew up bearings for the high power builds, so I just transitioned into using PDIs where I polished the shears and stuff like that, and I think they were great. So it looks like there's a small screw on the inside that you have to hold on to in order to screw that one out. Let's do that. On the floor. Okay. Go. Screwdriver. Pushy pins there. Ooh. So yeah, looks pretty basic. So when the piston pulls forward, this angled slope want to push this long part down, but the trigger blocks it. So once you push the trigger forward, it's able to move back and down. And it looks like we have a actual roller bearing on, let me point with something. This one looks like we have an actual roller bearing. I'm curious to see how well that holds up in the long run. Other than that, it looks pretty straightforward. Let's remove the safety thing. That's a 2mm. We will not ever be using this one again. For the other side. So yeah, that's my hair in the way. I hope you can see it. And it looks like we have an adjustment screw here for the trigger pull length. So yes, do we? Yeah. So I don't know if you can see it, but once we screw this one in, the trigger pulls further forward and we can adjust the trigger length pull there. I'll just leave it as is for now. We need to align everything. What is it? We don't have aligned. Oops. There we go. We need this one. Put in all these again. It's a pretty basic design, I would say. Looks nice. Let's see how well it holds up. I have another build going. That will be a high power build. I think I'll use the PDI one, that one, because I know that holds up for basically ever. And I'll use this one in my low power build. So in Denmark we can do 1.6-ish joule for CQB, 1.69 actually. And for high power build we can do up to, like, depending on where you play, you can go up to like 4 joules. I think the other build will be targeting 2.7-ish. But for this one, I think this will be the short version with this spring and the cylinder. And I think we will aim for like 1.6 joules with that one. So as you see, the shear is locked, able to pull back once you cock the spring. It's pulling forward and it should fire. Good. Yeah. Pretty straightforward. I really like the long cocking handle. I would say I have a aftermarket one where I buy them individually. It seems to be a bit nicer build quality with like 2-piece construction of like a nice milled one. This seems to be injection molded and then injection molded and then post-processed. So you can see a seam line down here and grinding mark from post adjustment to it. Anyway, let's put this one in again. This and this. And I initially wanted to do a compression test with the barrel as well, but if the piston is this poor, it doesn't make sense to do that anyway, so I won't be doing that for now. Let's put in this one. This system actually seems pretty nice, but it's a shame it's not a 9mm spring. I wonder if it will work with the 9mm spring shear as well. Yeah, nice. Let's take the hop apart. So, guess most of you know this, but we have 2 small screws here. It's basically the same construction for now as the regular VSRs. So you can see that this is not one of their Crazy Jet versions. It looks a bit like a regular version of a inner barrel. Don't know the diameter, but this is, as mentioned, their TDC-ish design, or whatever they call it, Maple Leaf hop-off post-production. It's still molded aluminum, I guess, but with a way stronger than the stock Marui one. This one used to be a plastic one, and I've had that break several times when it gets like really old and stuff like that. But yeah, it looks to be a nice metal one. It's a bit rough in the surface, so it could be concerned about the fine tuning of it, if it's like gripping on and releasing. There we go. So that's the one we know from Marui with the ankle slope pulling back and forth to open. There's a small retention spring there that does the clicky bit. So we have a nice aluminum BB retention. We have a O-ring out here to clamp onto the barrel. We have a maple leaf hop-up. It looks like the one where it doesn't come to a straight point, it comes to like two small points in the tip, with like a small triangle flat in the tip, but then with two small points. Yes, it's fine. Barrel looks fine. There's no markings on it. If we look at a regular Maple Leaf Crazy Jet barrel, we have the Crazy Jet porting system out here, and we have an engraving with Maple Leaf here. This was an old one from a used gun I got. Haven't tried it yet, but maybe I should try it in the future. Let me know what you think. I always run the PDI 0.1 and liked it, so never really tried anything else. Yeah, that's about it. I won't be putting it back together as I'm waiting for parts to do the actual build. Yeah, that's it. Just want to share what's inside, because it was really hard to find anything online. I will start looking into what I can do to get the cylinder more tight, because that seems a bit disappointing, I would say. Again, no compression whatsoever, but it was still shooting 2.7 joules, so it's not bad, but this should be able to hold pressure for like a long time, at least 10 seconds plus. So yeah, let's see.